Hello. This is Kumar Singh from Designed Analytics LLC, and you are watching the very first episode of Throwback Thursdays. Well, what will this video series be about? Throwback Thursday will be where we kind of go back into some of the key milestones, events in the history of technology, AI, machine learning that kind of helped change the landscape, helped change the game of these technologies. The very first episode will be focused on this research paper, which essentially helped kind of create a new path in the world of neural networks, deep learning, and gave us the transformer architecture, right? What the paper basically helped introduce is a novel encoder decoder model built entirely on self-attention mechanisms. So self-attention enables a neural network to refer to other portions of the input while focusing on a particular segment, right? Essentially allowing each part the ability to attend to the whole input, right? Keeping the context of everything. Now, the original attention mechanism developed for recurrent neural networks, RNNs, is applied between two different sequences, the encoder and the decoder embeddings, right? Now, since the attention mechanism used in transformer-based large language models is designed to work on all elements of the same set, it's known as self-attention. Now, an example of an attention mechanism used in RNNs to handle long sequences is Bahdanu attention. Now, I'm not sure if I said that right, but this is how it's spelled. This paper, this mechanism came in, I think, in 2014, right? So it was developed to make machine learning models, particularly those used in translating languages, better at understanding long sentences. Before this type of attention, the whole input, such as sentences in English, were squashed into a single chunk of information, and important details, as you can imagine, were getting lost, especially if the sentence was long, right? So in short, the original attention mechanism developed for RNN is applied between two different sequences, the encoder and decoder embeddings. For each generated output sequence element, the decoder RNN at the top is based on a hidden state plus a context vector generated by the encoder. And I apologize for some of the technical words, but since the paper is not so technical, it is a technical paper, so there will be some formulas and some technical jargon, right? Now, this context vector involves all elements of the input sequence and is a weighted sum of all input elements where the attention scores, say it's alpha, so attention scores alphas represent the weighing coefficients. What does this do? Well, this allows the decoder to access all input sequence elements, the context, right, at each step. The key idea is that the attention weights and the context may differ and change dynamically at each step. And the motivation behind this complicated encoder-decoder design is that we cannot translate sentences word by word. This is not how language works. So the Bahdanu attention mechanism relies on somewhat complicated encoder-decoder design, right, to model long-term dependencies in sequence-to-sequence language modeling tasks. Then 3 years after this, in 2017, in this paper, researchers worked on simplifying sequence-to-sequence modeling architectures. How? By asking whether the RNN backbone was even needed, right, to achieve good language translation performance. This led to the design of the original transformer architecture and self-attention mechanism, and we know where it led us, right? So what was in that paper, right? That was the context of what this paper helped with, right? And the concept of the paper, some of the technical details, what was in the paper introduced the original self-attention mechanism, also known as scaled dot product attention, right? Like I mentioned in the beginning, a novel encoder-decoder model built entirely on self-attention mechanisms, no RNN or convolutions, thereby allowing full parallelization of sequence modeling, right? Then it introduced scale dot product self-attention, which can be represented with this formula, right? Multi-head attention lets the model attend to different aspects of representation in parallel. it also kind of threw some light on positional encoding, right? So since no recurrence is used, fixed sino waves, positional encodings, not exactly waves, but sinusoidal positional encodings are added to input embeddings to encode token orders, right? Again, the formula for that is here for those who like to see the formulas, and that allows model to generalize longer sequences. It also kind of highlighted the layer structure, right? So both encoder and decoder stack features multiple layers combining multi-head self-attention and position-wise feed-forward networks. So that kind of summarizes the technical aspects of the paper. I hope you've found this useful and kind of get a decent feeling of why this paper is so important in the short, relatively, no, I wouldn't say short because AI we have been working for like almost half a century now, but relatively short timeline of AI. I hope you now understand what is the importance of this paper in the relatively short timeline of artificial intelligence. Thanks for watching. I will